Hello, dear students. Welcome to ARC Institute. I am Dr. R.K. Saini, and today I am going to discuss the D and F block element. This topic belongs to inorganic chemistry and it is very important for both JEE and NEET examination. It covers many important concepts, but in today's lecture, we will focus on their introduction, general electronic configuration, exceptional electronic configuration, metallic bonding, and related properties like as their melting point, boiling point, their atomization enthalpy, etc. So let's begin. First, we will discuss their introduction, particularly D block element. Those elements in which differentiating electron enter into d orbital are known as d block element. Differentiating means last incoming electron enter into d orbital are known as d block elements. On the basis, as we know, on the basis of differentiating electron, elements are classified into four blocks, namely S block, P block, D block, and F block. In second point, their general electronic configuration is n minus 1d, 1 to 10, minimum 1 and maximum 10 electrons are there. And in outermost NS, 1 and 2 electrons are there. However, some exceptional cases are also there in which no NS electron, like as in palladium. Third, their position, D block element are present from group number 3rd to 12 in long form of periodic table or in Bohr table, and they are present in period number 4 to 7. Period number 4 to 7. Next, most of the D block element, all D block element are metals. All D block elements are metals. These D block elements are also known as transition elements. However, transition element are those true transition elements are those in which d orbital are partially filled. D orbital are partially filled in their ground state or as well as in their any one of the oxidation state. Ground state means their elemental electron in form of their elemental electronic configuration, or in any oxidation state means in their any form of compound. For example, D block elements show variable oxidation state. For example, the Mn vary from +2 to +7 oxidation state also, and in any oxidation state when D block element, transition element in which d orbitals are partially filled. And hence, according to this definition, group number 3 to 11 are known as transition element only, because in group number 12, namely zinc family, zinc, cadmium, mercury and copernicium. Zinc, mercury and copernicium, their ground state electronic configuration is n-1d, 10 and ns2. Therefore, in ground state, d orbitals are fulfilled as well as their highest oxidation state. For example, zinc only show +2, cadmium only show +2, mercury show +1 as well as +2, and the copernicium in man-made element, therefore that its oxidation state may be up to +2. And hence, in their highest oxidation state, d orbitals are also fulfilled, and hence these elements are known as are not including transition element. Therefore, transition element are present in group number 3rd to group number 11. Group number 11 elements are known as coinage, for example, copper, silver, gold and And another element is Roentgenium, because their oxidation state are vary from +1, +2 or higher, +3 and +4. However, +1 and +2 are more common in case of copper, and these elements are also exhibit plus oxidation state +1 to +3, even +5. Silver also exhibit +5 oxidation state, and the most common oxidation state of gold is +3. It means their d orbital are partially filled, and hence the element of group number 11, copper family, are also included in transition element. Next, common property of d block element in mercury and copernician. Mercury and copernician are element which exist in liquid state. However, copernicium in man-made element. Therefore, only mercury is natural d block element which exists in liquid state. Other element of d block element are solid, no one gas. Technetium in first man-made element, atomic number 43. It is the element of group number 7 after manganese. Technetium in first man-made element, and most of the element of 6d series except actinium. Other are man-made element, and hence total 10 element in d block are known as man-made element or synthetic element. Total 40 elements are there in D block till date, and they arranged in 4 series, namely first transition series or 3D series, 4D series, 5D and 6D, and each series consists 10 elements. For example, in 3D series 10 elements. 3D series in 10 elements are there. 4D series also 10 elements. 5D, 6D, 3D series. The series scandium series start from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. It is the 3D series. Next 4D series. First element is deuterium, atomic number 39, and last element is cadmium, atomic number 48. It also consists an element. In 5D series, first element is lanthanum, atomic number 57, and the second element is hafnium, atomic number 72. And in 4D series, the second element is zirconium, atomic number 40. Here 14 elements are also there, and these elements are known as F block element or 4F series, and are also known as lanthanoids. And this series completed at the mercury atomic number 80. And in case of 6D series, 10 elements are also there. The first element is actinium, atomic number 89. Next one element in group number 4 is Rutherfordium, atomic number 104, and last element is copernician, atomic number 112 in 6D. Therefore, total 10 elements in 6D series are also known as. We know that after uranium, atomic number 92, other elements are man-made. Therefore, the 9 element in 6D series are man-made, and another element is technetium, first man-made element synthesized by Rutherford in laboratory by artificial means. Therefore, total 10 elements are synthetic, and the element of 6D series after actinium, or we can say after actinoids, are also known as post-Lawrencium element. Because these elements are present after Lawrencium. In actinoid series, the first element is thorium and last element is Lawrencium 103. Therefore, these elements are also known as post-Lawrencium element. And other simple introduction of D block element. Many elements have commercial importance. For example, the many precious elements like as silver, gold, and platinum are d block element. Platinum is the element of 5D series before gold, and silver is the element of 4D series, and many in industrial elements are also there. For example, copper, iron, and titanium. The iron and titanium are backbone of the steel industry. And this is the simple introduction of d block element. Now I am going to discuss their electronic configuration. Most common electronic configuration of d block element is n-1d, 1 to 10, and ns 1 to 2. But some exceptional electronic configuration are also there in d block element. Most of the exceptional electronic configuration are present in d block and f block elements. These exceptional electronic configuration arise so many factors, but the important factor are following. For example, the energy difference between outermost cell means ns and penultimate cell n-1d is very less, and due to less energy difference, first reason, due to less energy difference, electron are easily transferred from one orbit to another orbital in very easy. Second, half-filled extra stability of half-filled and full-filled stability. For example, D5 and D10. D5 and D10 are half-filled and full-filled electronic configuration. In these conditions, d orbitals are symmetrically arranged. They have equivalent energy, but their spatial arrangement is different, means their orientation different. And due to extra stability of half-filled and symmetrical electronic configuration, their shielding effect is very less, and hence outermost electron, or we can say the electrons, are tightly held with their nucleus, or nucleus has sufficient more attraction on their electron due to poor shielding effect. And next one factor is high exchange energy, value of exchange energy. Exchange energy is the energy released when electron instantaneously exchange their position in degenerate orbitals with same type of spin. For example, in case of d5 electronic configuration, d5, 5 electrons are present in degenerate orbital. Degenerate orbitals means the orbital which have equivalent energy, and the orbital which present in equivalent energy and have same spin. Notice the point. Degenerate orbital and have same spin are instantaneously exchange their position. For example, this electron instantaneously change their position with second one. This electron instantaneously change their position with third. This electron instantaneously with 4, and thus electron instantaneously change with 5. Similarly, this electron also exchange their position with these electrons, with this electron, and hence these electron also change their position, and hence total 10 exchange pair are there. And during this phenomena, energy released, and this energy is termed as exchange energy. And when energy released means that the system has low energy, and we know that the low energy is more stable electronic configuration. Therefore, some element so exceptional electronic configuration, because in their exceptional electronic configuration, their exchange energy is more, their poor shielding effect of half-filled and full-filled orbital. For example, in 3D series, copper, chromium and copper, so exceptional electronic configuration of above principle. First of all, we write their electronic configuration of 3D series, namely scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. The differentiating electron enter into 3D orbitals. The inert gas before 3D series is argon, and the differentiating First, according to above principle, the energy of 4s orbital is less than 3d. Therefore, 4s orbital are fulfilled and according to their capacity, and then electron enter into 3d. And hence, in case of scandium, 4s orbital fulfilled and the electron enter into 3d. In titanium, similar electron, 2 electron in S and 3 electron in D. In case of vanadium, in chromium, the electronic configuration is exceptional, and this exception explained with help of above 3 points, namely less energy difference between 4s and 3d. Therefore, electrons are easily transferred. Full half-filled electronic configuration. Half-filled electronic configuration of d orbital have symmetrical arrangement. Their shielding effect on one another electron is very less. Therefore, more attraction of the nucleus on electron. Therefore, this is the more stable and high exchange energy. We know that total 10 exchange pair are possible in D5, 3D5. Therefore, exceptional. In manganese, normal electronic configuration, 2 electrons. Then iron, 2 electron in S, 6 electron. 2 electron, 7 electron, 2 electron, 8 electron. Another exception in case of copper, atomic number 29, 1 electron and 10 electron. No exception in zinc. This exception is also explained with the help of these factors. In 3D10, total 20 exchange pair are there. Exchange energy is the energy released when electron in degenerate orbital have same spin or instantaneously exchange their position. For example, one type spin of electron exchange their position. For example, these 5 electron exchange their position instantaneously and hence total 10 electron exchange pair. Now another 5 electrons with opposite spin to first are also exchange their position instantaneously. Therefore, total 20 exchange pair, 10 clockwise and 10 anti-clockwise. These electrons exchange their position with red electron. With. Similarly, another electron, this, and total 10 clockwise, total 10, and hence total 20 exchange pair are there, and hence D10 electronic configuration is more stable due to high exchange energy, symmetrical arrangement of orbital, poor shielding effect of symmetrical orbital, higher attraction of nucleus on electrons. Therefore, exceptional electronic configuration is copper also there. And as 2 elements in 3D series have exceptional electronic configuration, namely chromium atomic number 24 and copper atomic number 29. Next, we discuss another electronic configuration of 4D series. 4D series. The element of 4D series are following. Deuterium. First element is deuterium, atomic number 39. Then zirconium, niobium, molybdenum, technetium, first man-made element, ruthenium, rhodium, palladium, silver and cadmium. Silver and cadmium. The inert gas is krypton before 4D series. And then after electron of fulfilled in chromium, the electron enter into 5s and then electron enter into 4D series. After fulfilled of the 5s, then 4D electron 1, zirconium same, but exceptional start. Exceptions are start from niobium. And these exceptions are very important and asked in many exams. For example, in case of niobium, electron, 5s electron only 1 and 4 electrons are there in d orbital. How can I explain this exception? No half-filled but high exchange energy in comparison to 3d electron. The exception also explained on the basis of less energy difference between 5s and 4d, first reason, and then we explain this exception electronic configuration with help of exchange energy. In case of 3 electron in d orbital, the exchange pair we consider exchange pair or exchange energy in 3D and 4D. If only 3 electrons present in D, then one exchange pair and one exchange pair and one. Therefore, total 3 exchange pair are there. But in case of 4 electron in D, total one exchange pair, then this exchange, and then total 6 exchange pair are there. And we know that when electron exchange their position, the released energy is known as exchange energy, and the species which have higher exchange energy get higher stability. Therefore, the electronic configuration of niobium is also exception explained with help of exchange energy as well as less energy difference. In case of molybdenum, also exchange, also exception electronic configuration like as copper, half-filled. In case of technetium, no exception. No exception because half-filled electronic configuration is more stable in most of the reference like as in J.D. Lee, inorganic chemistry, J.D. Lee, Hui, A.G. Sharpe, Mishler and Tar. The electronic configuration technetium is 4d5 and 4s2. But in your NCERT book, the exceptional electronic configuration also denoted in case of technetium. But in most of the references, no exception. In case of ruthenium, 1,7. Exception, rhodium, 1,8. Great exception in case of palladium, 0 and 10. Therefore, sometimes the electronic configuration of D block element is also written N-1D, 1 to 10 and Ns 0 to 2, including palladium, because no electron in Ns orbital, and explain on the basis of fulfilled electronic configuration, more exchange energy, symmetrical arrangement, poor shielding effect of symmetrical orbitals. Therefore, palladium 5s electron enter into 4d. Therefore, great exception. In case of silver is also exception like as copper. No exception in case of cadmium. That is the 4d series. Now we discuss electronic configuration of 5d series. Many exceptions are also there in 5d. Many exceptions are also there in 5d series. (5D series start from lanthanum atomic number 57. 5D series start from lanthanum atomic number 57. And the second element is hafnium atomic number 72. Because 14 elements present between lanthanum and hafnium are 4F series or lanthanoids atomic number 57, 58 to 71. And then next element hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold and mercury. Atomic number 57, 58, 72, 73, 74, 75, 76, 77, 78, 79 and 80. It is the series of 5D element. First, before 5D series, the inert gas is xenon, atomic number 54. Then electron enter into 6s2, and then electron enter into 5D. Then electron enter into exceptionally 5D in lanthanum. And actual means the electron enter into 4F. First electron will enter into 4F because the N plus L, according to N plus L rule, the energy of 4F orbital is less than 5D. But exceptionally electron enter into 5D, and hence lanthanum is the element of D block series. No electron in F, and then electron 14 electron enter into 4F orbitals. 4F. After 4F orbital are complete, then electron enter into 5D again. And hence, in case of hafnium, D2, S2, in tantalum, D2, S3, 14, in tungsten, no exception. However, this element present in chromium family. Chromium and molybdenum are exceptional electronic configuration, but no exception in tungsten. Notice very important point. No exception. D2, D4, 14. Rhenium, no exception. D2, D5, 14. Osmium, no exception. D2, D6, 14. Iridium, no exception, D2, D7, 14. Platinum, great exception. Platinum, D1, D9, 14. This exception asked in JEE in before 2 years. In gold, also exception, D1, D10, 14, like as other coinage. For example, copper and silver. And mercury, no exception, 2, 10, and 14. Therefore, the platinum. Now, check the electronic configuration of platinum. How can I explain this exception electronic configuration? On the basis of exchange energy only. Because D8 and D9, more exchange pair are possible in D9 rather than D8. And hence the exchange energy of D9 configuration is greater. However, it is not full-filled or half-filled electronic configuration. But the exception electronic configuration may be arise due to half-filled electronic configuration, full-filled, or to get more stability by the exchange energy in term of exchange energy. Next, we discuss electronic configuration of 6D series. Electronic configuration of 6D series. The first element of 6D series is actinium. We write there electronic configuration, atomic number, and IUPAC symbol also, because IUPAC symbol are also important and asked in many exams like as IIT-JEE 6D series. The first element is actinium, atomic number 89, and the second element is Rutherfordium, atomic number 104, because next another 14 element present between actinium and Rutherfordium are also a block element from atomic number 90 to 103 actinoids or 5F series. Next element, dubnium, atomic number 105. Next element, seaborgium, atomic number 106. Next element, bohrium, atomic number 107. Next element, hasmium, 108, metrarium, 109. Next element 1010 is dermstadium. Next element 1010 is dermstasium. Dermstasium. Thus IUPAC symbol is DS. Next element is 111 is Re, denoted by RT, and their name, IUPAC name is rontgenium. And next element or last element of 6D series is copernathium. Copernathium, Cn. IUPAC symbol is Cn. Copernathium. Cn. Atomic number 112. And the differentiating electron enter into 6D series. The inert gas is radon. After radon, the electron enter into 7s to then exceptional electronic configuration in 6D, and then 5f. And hence in case of actinium, 6D, one electron present in 6D, no electron in F, and hence actinium is also D block element. And then 14 electron enter into 5f in F block series. And now electron another again enter into 6D series. D2, no exception. D2, D3, no exception. D2, D4, no exception. D2, D5, no exception. D2, D6, no exception. D2, D7, no exception. D2, D8. Next. Now, exception in roentgenium electronic, like as other coinage, D1, D10, and no exception in copernathium, D2, D10, and 4F14. F5F14 submit. 4F 14, 14, 14, 14, 14. Therefore, only one exception in case of 5D series, particularly atomic number 111, ruthenium. This is the electronic configuration of a D block element. In the first time, I remember to you, in first time, when student achieve perfect score, 720 out of 720 in NEET exam, first time student achieve perfect score 720 out of 720 in NEET in 2020. Then a question asked about atomic number and their IUPAC notation as well as IUPAC symbol. IUPAC notation means of atomic number 101, atomic number 103, atomic number 106, and atomic number 111. We know that for one IUPAC notation. IUPAC notation unnil unium. In 103, IUPAC notation unnil trium. In 106, IUPAC notation unnil hexium. In 111, the IUPAC symbol ununium. And in IUPAC symbol is Mendelevium, Lawrencium, 106, Seaborgium, and Ananan, Rotengenium, RG. And this is the question asked from JEE NEET in 2020. First time the student achieve perfect score in NEET. Therefore, you mind remember IUPAC symbol as well as IUPAC notation of elements are also remember. Okay, this is the electronic configuration of element. And now we discuss physical properties of D block element. All D block elements, now physical properties of D block element. All D block elements are metals. All D block elements are metals. And metallic bond due to non-directional cohesive force between metal atom. Therefore, metallic bond is strong, and as most of the D block element are hard, except element of group number 12, zinc, cadmium as well as mercury. They are soft metal, low boiling point because weak metallic bond is there. All are metals. They have lustrous surface. Lustrous surface means their shining surface, and their fresh cut surface is silvery white except copper and gold. Their surface is golden or yellowish. However, other element, their fresh surface is silvery white, lustrous surface. They are good conductor of heat and electrical conductance. They possess all metallic properties. For example, they are malleable and ductile in nature, and they have high tensile strength, and they possess metallic crystalline structure. Metallic crystalline structure. And the most common crystallized structure are cubic closed packed structure, hexagonal closed packed structure, and bodies centered cubic structure. Except manganese, zinc, cadmium, and mercury. These four elements in D block. Other D block element possess one or more crystalline structure at normal temperature. And as these elements are also so polymorphism. Polymorphism means that more than one structures are there. For example, the first element of group number 3rd. For example, scandium, yttrium, and lanthanum. Their common structure is HCP, but they also form BCC type of crystals, and in lanthanum also form BCC as well as CCP structure also in addition to HCP. HCP structures are also there. For example, in group number 4, the scandium, titanium, deuterium, zirconium, and hafnium also exhibit HCP structure at normal condition, but they also exhibit BCC arrangement. In case of copper, silver, and gold, they have CCP structure at ordinary condition, and hence some element of d block element are polymorphic. Polymorphism means they possess more than one physical appearance or crystalline structures, and these are the physical properties. And in another class, we discuss their another properties like as their metallic bond and related properties, and another oxidation state, color, etc. Okay, thank you.